Hey guys, what we're going to be doing today is we're going to be continuing on our talk on the Grand Canyon rocks. So as you guys know, we're working as geologists and we're trying to learn what geologists do, which is study rocks, landforms, and anything inside the earth. So what we did in class on Friday is we did the acid test. Now the acid test, basically what it was is we were taking hydrochloric acid and putting a drop on a rock, and we were taking a look and see what would happen. Now there are two possible responses. There was either fizzing, you could see the actual fizzing, or you could actually see nothing happen. So you had two possible reactions that could have happened, or two possible observations that you would have been able to see in our acid test. And I will tell you, that tells us a lot about the composition of a rock, what a rock is made of. So what we need to talk about first, in order for us to understand this whole acid test, we need to talk about what everything is made of. Everything is made of elements. Now, you may have heard of the periodic table of elements, you may not have, and that's perfectly fine. But many of you guys know what H2O is. Water. H2O is made of hydrogen. It's one of our elements that we can find here on Earth. Oxygen, that's another element. And when you go ahead and combine two hydrogens and one oxygen, you get water. So it's one of those things I want to make sure you all understand, is that this periodic table of elements helps us understand a little bit more about what everything is made of. So when you think about the acid test that you did, we started with two things. We started with acid in a rock. And basically what we were trying to do is we were trying to see what would happen. Now, if something happens, when you put two things together and something new happens, or something like out of the blue happens, most likely we're talking about a chemical reaction that's occurred. Now, a chemical reaction is just when you took two chemicals together and they form something new. A new chemical comes up. That's what we're talking about when we're talking about a chemical reaction. Now, a chemical reaction, when we know that something's happened, we are not able to take those pieces apart. So once we put the hydrochloric acid onto the rock and we started to see it fizz and bubble, we would never be able to take those two things apart again, because we created something new. One of the other signs that you have had a chemical reaction occur is when you go ahead and you put two things together and then you can't take them apart. So like, say for example, I'm going ahead and baking a cake. I go ahead and put flour, eggs, I might put a little bit of baking soda, salt, oil, and water, and I go ahead and mix it together, and then I go ahead and throw it in the oven. I can't get those things to separate back out. We know that a chemical reaction has occurred. So when I get the full cake, I can't take the baking soda or the egg or the salt out once it's baked, once it's cooked. That our acid test is looking for a chemical reaction, because we're trying to identify when we have a chemical reaction, there's what's called the reactants. Those are the things that we start with. So if you think about it, we started with our hydrochloric acid and our rocks. And we ended up making something new. That would be a product. So if you take a look at the equation, our chemical reaction, we actually it's like a little math equation. You have the reactants on one side, the things we start with that react together, and then you have this little arrow, and that little arrow is kind of showing you that it goes in a certain direction, that this chemical reaction, that these things are going to make something. And then that's the product side. So obviously when we went ahead and put hydrochloric acid on our particular rock, we saw fizzing. And that's our sign that we made something new. So we have a new product with our chemical reaction, with our acid test. Now, it works sometimes for some of the rocks. We saw a chemical reaction occur. We saw something new. We saw the fizzing. Other ones, we didn't see anything. So in this case, there was no chemical reaction. When we don't see anything happen, we have no sign of chemical reaction, there's no chemical reaction that occurred. So no new product. So on some of the rocks, you saw nothing new. Alright, so what we were really trying to do is we were taking this acid test to try to test for calcite. Trying to go ahead and see if there's a particular mineral called calcite in the rock. And if there is, it tells us we have a certain type of rock. So calcium carbonate, which is CaCO3, that is what is calcite? Calcite is a natural form of calcium carbonate. It's found in the ground. It's found in it's a mineral. It's found in many rocks. And this calcium carbonate helps us understand that we are dealing with limestone. So if we happen to go ahead and take our acid and we put it on a rock that has calcite in it, what will end up happening is we'll see the fizzing in the bubbles. Putting hydrochloric acid on calcium carbonate creates a new product. So that's our sign that we are dealing with limestone rock. And that's something really important. As a geologist, we need to be able to identify types of rocks. And so acid test helps us do just that. So here's the actual chemical equation for what we just did. And it's important that you write this down. We had hydrochloric acid, which is our HCl, so hydrogen and chlorine together make hydrochloric acid. And what we did is we went ahead and we put that on a rock. And then when we put it on limestone, which has calcite in it, or calcium carbonate, we then formed a new chemical. We formed the fizzing or the bubbling. We saw that happen, which is really carbon dioxide gas being formed. When you go ahead and you put hydrochloric acid and calcium carbonate together, you create calcium chloride, which is a salt, a little bit of water, and then a gas, carbon dioxide. That's something that's going to be important that we're going to come back to, and we're going to talk a little bit more about in class, but I do want to make sure that you have this chemical equation written down so we can make sense of this a little bit more. What I want you to do then, right now, is look at your actual data from our acid test, and any of the rocks that were fizzing or bubbling, I want you to label limestone. Those are the ones that we need to make sure we talk about next in class, and I want to make sure we're able to identify which numbers of those rocks were considered limestone. If you happen to have any questions, make sure you feel free to ask me, and I'll see you in class. Bye.